Both APD and SIP layout have a DXF import function that can be used in conjunction with the compose shape functionality to begin building a package design from information imported from DXF data. We'll begin our example by starting a new design in Allegro Package Designer. In the new drawing configuration form, we'll select a wire bond chip up design. The DXF data we'll be importing is for a lead frame package, and we'll be wire bonding an IC to the lead frame. By selecting a wire bond package type in the design configuration form, we ended up with a wire bond layer in our design. DXF data can be obtained in a variety of different ways. For example, many lead frame vendors supply their lead frame data as DXF files on the internet that can be downloaded for use and imported into the Allegro Package Designer. To begin the import process from APD, we'll select File, Import, DXF to open the DXF Import form. We'll navigate to the location of our DXF file. The DXF format is an ASCII text format, but is not uncommon to not know what units were used in the DXF file. We'll assume that our DXF file units are millimeters. And after the import, we'll check to make sure that our lead frame appears to be the correct size. The DXF file import requires a conversion file that will convert from DXF layers to APD classes and subclasses. If you do not have a DXF conversion file, we can have one created for us by selecting the Edit View Layers button in the Conversion Profile section of the DXF In form. The DXF layers from the DXF file were read by APD and are listed in our DXF In Edit View Layers form. It is also not uncommon to not know what layers were used in the DXF file you're importing and what information might be on those layers. If you're getting the DXF file from the same people all the time, you may reuse your layer conversion files and map specific DXF layers to specific APD classes and subclasses. In our case, we see the DXF layers that were used, but have no indication of what type of data is on each layer. Since we don't know what type of data is on each of the layers, we'll want to import all of the layers and look at the data. And again, this might be an iterative process to determine which layers we want to import and what classes and subclasses we'd like to import them on. We'll select the Select All button in the Edit View Layers form to select all of the existing DXF layers, and we'll map them to the manufacturing class. And by selecting the Use DXF Layers as Subclass Name checkbox, APD will automatically create a new subclass under the manufacturing class with a name that matches the DXF layer when we select the Map button. And as we can see in the layer conversion file form now, each DXF layer maps to the manufacturing class and a subclass with the name of the DXF layer. When we pick the OK button, the DXF layer conversion file is written back into our current working directory. DXF data had a border outline, which we can discard. And if we zoom in, we can see the lead frame information that's been imported into APD. All the data was imported into subclasses of the manufacturing layer, so we can go to the color and visibility form. And if we individually turn on each of our new subclasses under the manufacturing layer, we can see that the 0 subclass has most of the lead frame fingers that we'll need for our APD design. As we turn on the other classes and subclasses, we find that most of those subclasses were used for either the border outline or simply not used in the DXF file. By assigning different colors to the different subclasses, we find that most of our data is on the 0 subclass, with smaller amounts of data on the Frame 2 subclass, as well as the Mold subclass. As we zoom in, we'll notice something interesting about our lead frame fingers. We notice that they're constructed of segments rather than shapes in the DXF, and also in some places, the DXF subclass, or the DXF layer that was used, is not consistent. So notice this finger that we see here, most of that finger is on the 0 subclass. However, one of those line segments is actually on the frame 2 subclass now, instead of the 0 subclass with all the other layers. This is just the way the DXF was created, and we have no control over it. All we can do is work with the data we've got. What we'd like to do next is create shapes out of our lead fingers. These well, they're not even polygons, these lines. We'd like to build shapes out of them, as well as the large shape in the center of the lead frame. The compose shape command will help us turn the segments into shapes. If we zoom in to some of the lead frame fingers, we can see the shapes that we'd like to make polygons out of. Unfortunately, rather than being individual line segments, the top segment of each polygon that we need to create is constructed of a single line rather than individual line segments. Fortunately, the compose shape will help us accommodate this problem anyway. We'll leave our mold subclass off before we start the compose shape command. To compose shapes from those line segments, we'll select the shape Compose Shape command from the APD text menu. We'll draw a window that selects 3 segments from the die flags that we'd like to create a shape out of, and we see that the 3 segments highlight in the user interface. Notice that down on the command line, APD indicates that the 3 line segments we created do not create an enclosed shape, and then we can use the Close Shape option from the right mouse button pop-up to have it close the shape for us. So if we hold down our right mouse button, we can select the Close Shape option, and we can see that the shape was created for us on the layer indicated in the options form, which we had set to Conductor Surface. So the shapes will be put on the top layer of our package design. We're still in the Compose Shape command, so we'll hold down our right mouse button and select the Next option to select our next set of line segments. And we'll select the next set of line segments for the next finger, and we'll right mouse button and select Close Shape again. And again, we'll select the Next button and move on to the next set of Connect line segments. We've now created shapes for each of the lead frame fingers, and we need to build a shape from the large shape in the middle of the lead frame. If we zoom in to one of the corners, we can see that the shape is currently open in each of the 4 corners. And if we go back to our color visibility form in our manufacturing class, and we turn on the mold subclass, we'll see that that's where the closing line for that shape is. However, again, as instead of being a single segment that just connects from one vertex to the second vertex of the shape, it's one large shape that goes all the way around the lead frame. So we'll leave the mold subclass off, and again, the compose shape command will help us close that shape and build the required shape that we need. We'll restart the Compose Shape command by selecting Shape, Compose Shape from the APD text menu. In our options form, we'll make sure that we have our class and subclass set to Conductor and Surface. The shape that gets created is going to be placed, again, on the top layer of our design. Since we need to select a bunch of line segments and can't do it with a simple rectangle, we'll hold down our right mouse button and select Temp Group. And that will allow us to select individual line segments to add to our temporary group. And we'll select each of the segments that make up the shape that we'd like to compose. Now that we've selected all of the existing segments, we'll right mouse button and select Complete to complete our selection operation. We'll then turn off the Use Auto Gap checkbox and select a maximum and increase the size of the maximum gap. Notice that our shape has now been closed for us. Any vertices that are closer together than the maximum gap that we set will be automatically closed for us, which closes our 4 connections in each of the 4 corners of our lead frame. And when we right mouse button and select Done, we can see that the large shape in the center of our lead frame is now created as well. The shapes that we now have were imported from a DXF file, so we'll want to consider the origin of our design. In general, most APD designs are done with the 0, point of the design being the geometric center of the lead frame that we're creating. If we put our cursor near the middle of our lead frame, our coordinates are indicated at the bottom of the APD user interface, and we can see that the center of our lead frame is not currently at 0. We'd like to move our origin or 0, point of our design to the center of our lead frame shape geometry. One easy way to accommodate this is to add a temporary circle at the geometric center of this shape that we've created. So we'll select Add Circle from the APD text menu, and we'll add a circle on the conductor base layer. We'll eventually be deleting this circle, but for now what we'll do is right mouse button and select the Snap Pick to Shape Center. And that will automatically snap the center of the circle that we're adding to the center of the shape we are hovering over. And we'll just place a small circle towards the middle of that lead frame. Now, if we zoom in on that circle, we can use the Display Element command to find the location of the circle we've just added. The Show Element window shows the location of the center of that circle, and we'd like that circle to be right at 0, the origin of our design. We'll select the pin on the Show Element window so that the window will stay open even after we close the Show Element command, and we'll select Setup Design Parameters to open our Design Parameters form where we can move our design origin. We'll first move our X coordinate to where that circle is currently located in the X direction. And similarly, we'll move our Y coordinate to where that circle is currently located. And after moving our design origin in the design parameters form, we can see our origin indicator in the user interface, and when we hover our mouse over the center of that circle, we can see that the origin of our design is now the center of the shape that we had imported from the DXF file. And we'll close our Show Element window, and we can delete the temporary shape that the temporary circle that we created so that we can easily move our design origin. So now we've used the DXF in command to import DXF information and the compose shape command to compose shapes out of the individual line segments in the DXF file to give us shapes on the top conductor layer of our design.